Hello and welcome to this video. We're going to learn about the quotient rule. So if we have a function in the form of a over b, the derivative of such a function, d over dx of a over b, will be, so this will be b you multiply by the derivative of a minus a you multiply by the derivative of b all over b squared. So that is a general formula of the quotient rule. So we can look at a few examples. 3x squared over 5x minus 3. So using the quotient rule, let's find the derivative. So we need to identify a, we need to identify b, we need to find a prime, and we also need to find b prime. So in this case, a is 3x squared, b is 5x minus 3, a prime will be 6x, b prime will be 5. So let's substitute this in the formula. So we have b as 5x minus 3. We multiply by 5x minus 3, we multiply by a prime, which is 6x, and then minus a is 3x squared, you multiply by b prime, which is 5, all over b squared, which is 5x minus 3 squared. So let's work out this. Let us first start with the numerator. So in the numerator, we are going to have 30x squared minus 18x, and then, okay, let me write this properly. So minus 30, not 30, but 15x squared all over 5x minus 3 squared. So in the numerator, we're going to put like terms together to give us 15x squared minus 18x all over 5x minus 3 squared. So using the quotient rule, that will be the answer. So let's look at another example. So 3x cubed minus 5x over 4x squared minus 3. So we need to identify a, we need to identify b, we need to find a prime, and we also need to find b prime. So in this case, a will be 3x cubed minus 5x, and then b will be 4x squared minus 3. So a prime in this case will be 9x squared minus 5, and then b prime will be 8x. So as we said, the formula or the quotient formula is b a prime minus a b prime all over b squared. So we are going to substitute this in this formula. So b, we have b as 4x squared minus 3, and then a prime is 9x, let me write this properly. So b prime is 9x squared minus 5, and then minus a, which is 3x cubed minus 5x, and then b prime is 8x, and then all over b squared, which is 4x squared minus 3 squared. So let's work out this. So in the numerator, we are going to open this bracket. So in the numerator, we are going to have 4x squared. We multiply by this other bracket, 9x squared minus 5, and then minus 3. We multiply by 9x squared minus 5. So for this other part, we're going to have negative. So we're going to have 24x to the 4th power, and then minus this will be 40, 8 by 5, 40x squared, and then all over 4x squared minus 3 squared. So let's work out this. So in the numerator, we're going to have 36x to the 4th power minus 20x squared, and then minus 27x squared, and then plus 15. And then for this other part, we're going to have minus 24x squared, or rather 24x to the 4th power, plus 40x squared, and then all over 4x squared minus 3 squared. So putting like terms together, we're going to have 36x to power 4, and we also have negative 24x to power 4. So this will give us 12x to the 4th power, and then we also have negative 20x squared. We also have 40x squared. So this will give us plus 20x squared. Then, we also have another x squared, that is negative 27x squared. So when you put all these like terms together, we're going to have negative 7. We're going to have negative 7x squared, and then plus 15, and then all over 4x squared minus 3 squared. So using the quotient rule, that will be the answer. So we can also look at another example. Sine x over cosine x. Let's find the derivative of this using the quotient rule. So we need to identify a, we also need to identify b, we need to identify a prime, and we also need to have a b prime. So in this case, a is sine x, b is cosine of x, a prime will be cosine of x, and then b prime will be negative sine of x. So we also have the quotient formula, as we said earlier, is b a prime minus a b prime all over b squared. So we are going to substitute this in this formula. So we're going to have b, which is cos x, we multiply by a prime, which is another cos x, and then minus a, which is sine x, and then multiply by b prime, which is also negative sine x, and then all over b squared. B squared will be cosine squared of x. So let's work out this. So in the numerator, we're going to have cos x by cos x to give us cosine squared x, and then negative sine x by negative sine x will give us positive sine squared of x, and then all over cos squared x. So cos squared x plus sine squared x is the same as 1 over cos squared x. So 1 over cos squared x is also the same as secant squared of x. So what does that mean? So we all know that sine of x over cosine of x is the same as tangent x. So this means the derivative of sine x over cos x is the same as the derivative of tan x, which is also equal to secant squared of x. So let's look at another example. 1 over cos x. So let's find the derivative of this function. So we need to identify a, we need to identify b, we need to identify a prime, and we also need to identify b prime. So in this case, a is 1, b is cos x, so a prime will be 0 and b prime will be negative sine x. So using the quotient rule, let's find the derivative. So we have the quotient formula as b a prime minus a b prime all over b squared. So let's substitute this. So we're going to have b, which is cos x, we multiply by a prime, which is 0, then minus a, which is 1, and then we multiply by b prime, which is negative sine x, and then all over b squared. B squared in this case will be cosine squared of x. So in the numerator, this is going to give us 0. Cos x times 0 will be 0. So we're going to be left with negative 1 times negative sine x to give us sine x all over cos squared of x. Alright, so this we can rewrite it as 1. We can also write it as 1 over cos x, we multiply by sine x, over cos x. So, and we all know that 1 over cos x is the same as secant of x, and then sine x over cos x we all know is the same as tan x. So this simply means that the derivative of 1 over cos x is the same as the derivative of 1 over is the same as the derivative of secant x, and is also equal to secant x times tangent of x.